around the world. Okay. All right. I work with customers around the world, and as well, along with our Arista partners, and helping our customers understand the technologies, and really help solve problems for them and their pain points.
Wonderful. All right, next slide.
Yep. Go ahead.
Okay. This is kind of the agenda that we put together for you. We'll briefly introduce what Arista Networks is all about. Then we're going to look at some of the trends that are driving, kind of uplift from 25 gig to 100 gig to 400 gig. We're going to talk a little bit about market forecasts and look at kind of where the server connectivity is headed. Then we're going to look at the typical architecture for the enterprise data center and the new hardware and transceiver technologies that is enabling them. And then, Gary's going to spend quite a bit of time on kind of, how do you think about sort of cabling and connectivity? And we will leave the session with giving you some thoughts on kind of the campus applications and the associated cabling design. Next slide, please. So oftentimes when customers sort of think about Arista Networks, the first thought that comes to mind is around data center networking, which is obviously kind of the use case that we started with. Customers obviously have data centers to connect their apps. Oftentimes data centers are built using sort of leaf spine networks. In our case, we also pair the switching with management platform called Cloud Vision. Similarly, we then extend that same architecture into campus with the, campus is really focused on kind of the device connectivity aspects. And again, we use similar switches to build campus networking, of course, taking into consideration that you need power over Ethernet, Wi-Fi within campus and user connectivity scenarios. But we then also use Cloud Vision to manage that particular environment as well. Now, do keep in mind that Arista does a lot of other things that includes observability, security, cloud connectivity, and routing. But today's focus is really just going to be on the data center and the campus networks. Next slide. Let's kind of look at kind of some of the trends that are kind of driving, the upgrade within the data centers. The most common trend that we are seeing is sort of servers moving from 10 gig to 25 gig. That's kind of the most predominant trend. When servers move from 10 gig to 25 gig, naturally, sort of the links that are deeper in the network from top of rack switches to spine switches, naturally customers sort of think about upgrading those links to 100 gig links. But there is also kind of a small percentage of data centers where customers are going to 50 gig NICs or 100 gig NICs for specialty applications, which is then going to not sort of so much force the customers, but sort of consider, upgrading even the spine links from 100 gig to 400 gig. So that transition is underway. Certainly the most predominant transition being 10 gig to 25 gig transition on the server side. Also commercially, this transition makes sense because you're getting a 2.5x the performance upgrade, but it's not like the 25 gig is 2.5x of the 10 gig in terms of the commercial aspect. That generally works out in the favor of the customers who are doing the upgrade because you do get much more performance benefit without taking on the pricing burden. So so the price performance ratio works out when you do these upgrades. The next aspect is there's obviously a lot of east-west traffic within the data centers. Again, you're going to have workloads that are going to be 25 gig, 100 gig, 400 gig. So we're going to have to sort of account for that. There's a kind of a new class of applications, particularly in AI, ML. I mean, every day that you talk to people today, people talk about Chat GPT. There are similar applications, that various enterprises are experimenting with, whether it's healthcare, whether it's universities, whether it's autonomous driving. AI and ML is becoming kind of this really a business driver for a lot of enterprise customers. And what that means in terms of network connectivity, we're going to start to see a lot of 50 gig, 100 gig endpoints to connect the GPUs within those AI and ML clusters. There are, of course, media consumption is on the rise. That also requires a lot of bandwidth as well. And also when customers, obviously for redundancy purposes, sometimes, active, you need DCI connections that tend to be very high speed, 100 gig today. A lot of customers are considering, that to be kind of the first place to consider 400 gig connectivity as well, or at least N by 100 gig. When you look at the cloud is a whole other sort of beast in that way, that they are generally at the cutting edge, at the front end of all of these transitions. Here we are talking about in the enterprise space, customers going from 10 gig to 25 gig, whereas in the cloud data centers, there is also, as you will see in the chart in my next slide, there's also a large percentage of servers with 50 gig NICs, and they're already moving in the 200 gig, 400 gig direction from the compute connectivity perspective, which naturally means that they're looking at 800 gig, 400 gig interconnects within the data center. And this last point that I'm making is really more relevant to the enterprise, not so much to the data center. That remote working is pretty common. We are coming to you over Zoom, and that generally sort of obviously drives more traffic within the data center wherever these applications are hosted. Next slide, please. If you can, just do the build one more, please. So I want to draw your attention to where kind of the server connectivity is going. Sort of ultimately, sort of all of the network transition starts there. Just sort of keep in mind, that's kind of the first connectivity point within the network, and then the top of rack switches, the connectivity with the spine switches and beyond, sort of, all of your thinking is going to kind of start from there. So if you look a little bit into the future, what you will see, particularly in the enterprise data centers, if you look at my slide on the left side, what I'm showing is kind of, what are the trends within the enterprise. On the right side, what I'm showing is what are kind of the trends on the cloud data center side. So if you can focus our attention on the enterprise for a moment, what you will see is that 10 gig and 25 gig certainly remain kind of the predominant connectivity model for years to come. 100 gig server connectivity will become more common in the coming years. So 10, 25, and 100 seems to be kind of the predominant connectivity models. Of course, we see 50 gig, we see 200 gig, but, kind of in terms of the mix, those, connectivity options seem to be in lesser demand compared to 10, 25, and 100. But on the flip side, if you look at sort of the cloud data centers, over there, 100 gig is really kind of the most predominant connectivity option that's emerging over the next few years. Of course, in the cloud data centers, you also see 50 gig, you also see 200 gig, you see some 25 gig, and almost 10 gig is sort of non-existent. So over there, it's really 100 gig and beyond is sort of, accounting for much of the server connectivity in the enterprise data centers. 10 gig, 25 gig, and some 100 gig is what's going to kind of drive the server connectivity. And certainly why we show this data is because kind of that's sort of where the entire sort of, build out of the data center starts. So if you go back to, there's a question in the chat, the Delora forecast. I mean, if you look at it, it's from this year actually. So it's pretty, Gary, if you can kind of go back a slide for just a moment. So yes, sorry, I know we did not kind of mention the year, but this particular forecast from Delora is from this year, and it kind of takes us, up to 2026, as you can see on the slide. So just thank you. And next slide, please. What we try to show you in this particular slide is sort of, really kind of a couple of pieces of information. This is a typical standard data center design kind of, within Arista that we propose to our customers. Of course, there are other aspects of the data center network, but if you look at just the fabric that we built to connect servers and, how those servers can communicate to each other, we call it kind of the leaf spine network. So, what we are starting to see is, if you look at the server connectivity, predominantly that's all 10 gig today. It's starting to move towards 25 gig. And if you look at these uplinks over here, that's where, from the top of rack switch to the what's listed as universal spine on the slide, a lot of the customers have those networks as 40 gig today, but they are sort of doing the transition to 100 gig. What we will see is, down at the server level, of course, 25 gig is becoming predominant, but in some small capacity, we'll start to see 50 gig, 100 gig connectivity as well. And when you have 50 gig and 100 gig, down at the server level, customers would want to consider from the top of rack to spine connectivity to potentially be even 400 gig with the backward compatibility to 100 gig. So that's kind of what we are starting to see. Next slide, please. Little bit about kind of the Arista portfolio. I would be the first one to tell you that Arista portfolio is very, very broad. And this slide does not even begin to kind of scratch the surface of what we can, give you in terms of the building blocks for your network. But really, since I said at the top of the hour that, our focus of today's discussion is going to be on the data center, the 7050X platform, as we commonly refer to as X3 and X4 in particular, are the predominant platforms that we use to build data center, whether you're thinking about the server connectivity or the spine connectivity. So if you look at from the left to right, we have obviously the X3 platforms that provide you the 10 gig, the 25 gig, and the 100 gig connectivity, and the X4 platforms on the right that are kind of the new platforms, which I will get into in just a moment, that provide you that 100 gig to 400 gig connectivity. So the most interesting piece about the X4 platform is not only does it get you ready for that 100 gig to that 400 gig transition, but it does so with keeping in mind the backward compatibility all the way down to 10 gig and 25 gig. So if you are sort of that forward-leaning, forward-thinking customer, you may want to kind of consider even thinking about building networks with these building blocks, that sort of really set you up for the next 5 to 10 years in terms of the speed, the performance, and the bandwidth growth. Just do keep in mind that X3 and X4 are kind of just the different versions or classes of the chipset. X3, commonly referred to as sort of Trident 3, X4 commonly referred to as Trident 4. But what's more important is, if you look at kind of the bandwidth jump, going from 3.2 terabit up to 12.8 terabits. So we are really looking at, 4x generational improvement in bandwidth capacity, going from just one generation of chipset to the next. This is truly, truly incredible. And again, ultimately, the beneficiary of this sort of performance growth is going to be the end user and the applications, because again, even though the performance is 4x, commercially, these systems are not 4x more expensive than the previous generation. So, really, ultimately, you're going to benefit from that price performance increase. Next slide, please. We like to obviously, give you kind of a little bit of a blueprint of, what systems to consider when you are thinking about kind of different building blocks. So if I go from top to bottom, naturally, a lot of the customers today are thinking about building their spine networks or spine building block with 100 gig switches. And in that area, we typically recommend the switches that I've listed here, 32 by 100 gig or 64 by 100 gig. Or if you have a more sensitive environment, or if you're looking at a data center interconnect application and you need encryption, then we obviously offer sort of the same version of that particular platform with MACsec built in or layer 2 encryption built in. So, you have options with MACsec or without MACsec. If you take a kind of closer look at the naming convention, you will see some switches have that letter M in the name. That generally means that, this particular switch also supports layer 2 encryption. Now, when you look at the 25 gig line, again, one of the things that you will come to hopefully appreciate about Arista is that we offer lots of flexibility and a lot of options to our end users. So if you look at the 25 gig options, we have the 96 port switch with 8 by 100 gig uplinks. And again, if you have very high density server connectivity requirement, then that's a very, very good option to consider. If you look at the switch in the middle that has 48 ports of 25 gig, but 12 ports of 100 gig uplinks. And again, if you are building those ML/AI applications, you need a completely non-blocking environment, then that's a perfectly good top of rack switch to consider. Our most common top of rack switch is the one on the right with 48 ports of 25 gig and 8 ports of 100 gig, because for most enterprise applications, that kind of oversubscription ratio is perfectly fine and normal, and and again, of course, it's going to give you some price advantage there. And if you keep going down below, we have obviously 10 gig copper connectivity. A lot of times customers have switches, servers with copper 10 gig ports. So obviously you need an option for that. And although we do recommend customers, if you're building a network today, you should really just start with a 25 gig as the baseline, because all 25 gig ports can be stepped down to 10 gig. But if really commercial consideration is there, we also offer an option with purely just 10 gig connectivity option as well, the 7050 SX348C8. And down at the bottom, of course, no network is complete without sort of taking into account the management connectivity, IPMI connections, all of that out-of-band network. And the nice thing is that you can use the 7010TX platform, supports the same set of features and capabilities that any of these other high bandwidth switches support as well. Next slide, please. Now, this is sort of really the exciting slide. Of course, the 10 gig, 25 gig, 100 gig, that's sort of, people are familiar with those building blocks. That's how customers are building networks today. But I really want to kind of leave you with some food for thought, that if you look at some of these newer platforms that Arista is introducing, this is sort of really exciting for us. If you look at this particular platform at the top left, the 7050 SDX4 platform, this is the first platform where you can get 100 gig connectivity over an SFP form factor. Now, just stop for a second, because today 100 gig connectivity is really only possible with the QSFP form factor. This is the first platform that's introducing 100 gig connectivity over small form factor, or SFP as we call it. Again, very exciting, because you have now 48 ports of SFP. And again, you can connect a 10 gig SFP, it becomes a 10 gig port. You connect a 25 gig SFP, it becomes a 25 gig port. You connect a 50 gig SFP, it becomes a 50 gig port. And you connect a 100 gig SFP. Today 100 gig SFP is really only available in a cable form factor with DACs and things like that, no optics, but it becomes a 100 gig port. So really, think about that, 4 generations of server connectivity on the same box. This is an incredible future proofing, that you can connect a 10 gig server all the way to 100 gig servers on these 48 ports. And then the uplinks are 8 ports of 100 or 400 gig uplinks. And again, this is a QSFP form factor. So you can either just use QSFP 100 gig or QSFP DD is 400 gig, or break them out into 4 by 100 gig ports to get more density. So really, really flexible, versatile platform for next-gen server connectivity. Do keep in mind, we do not recommend that you use this particular switch as a spine switch, because typically in the spine role, you're going to need some kind of an optical connectivity, and the SFP-DD form factor does not support optics today, at least. If you look down below, that's, again, a perfect platform for spine connectivity, gives you 48 ports of 100 gig with 8 ports of 400 gig. Of course, this retains the QSFP form factor, because a lot of times people, again, like I said, this is optimal for spine connectivity because it has the QSFP ports. And last but not the least, if you look to the right, that's another platform that we're very excited about. It gives you 24 ports of QSFP. And again, you can use them for 200 gig connectivity, which is less common in the enterprise, or break out each of the 200 gig port into 2 ports of 100 gig, thus giving you 48 ports of 100 gig in a 1 RU form factor. So again, very, very interesting. So it's very similar to this 2RU platform that I'm showing on this particular slide, except that you get the same 100 gig density in a 1RU form factor. But do keep in mind that that requires a breakout capability of each ports of 200 gig into 2 ports of 100 gig. But again, for lots of people, space is a big constraint. You want to get better power efficiency and things like that. Then you can kind of lean towards this 1RU platform instead of a 2RU platform. So very, very interesting new form factors that we are bringing to market for particularly 100 gig, downstream connectivity and 400 gig upstream connectivity. Next slide, please. And again, naturally, if you're sort of going in that direction of 100 gig connectivity to broad spectrum within your data center or some parts of your data center, you're going to have to consider 400 gig as your spine or aggregation. And this is sort of one of the platforms that we have introduced, 32 ports of 400 gig in a 1RU form factor. Now, do keep in mind, and Gary will touch on this, that when you get to 400 gig, you have sort of a choice to make in terms of the optical connectivity. You can, of course, choose QSFP, DD optics, which gives you a ton of backward compatibility to 100 gig and 25 gig and so forth. But, you can also choose OSFP. OSFP gives you much better thermal capacity in terms of the optics reach and ZR and things like that. And do keep in mind that as we go to 800 gig or 1.6 terabits, OSFP is going to be a more predominant form factor. So what I'm sort of laying out here is, when you think about 400 gig, Arista is always going to offer you two options in terms of the port connectivity. We're going to give you options in QSFP, and we're going to give you options with OSFP. So if you look at the part numbers itself, the DX part numbers refer to QSFP ports, and the PX part numbers refer to as OSFP ports. Next slide. Now, in many cases, sort of, customers sort of don't like the breakout pieces. Of course, if you look at the 1RU 400 gig switch, the way you can get 400 gig, 100 gig, capability or 25 gig is through breakouts. But some customers want native ports. So we also offer this, what we call as kind of this hybrid option that's sort of a semi-modular platform, kind of a mix between a fixed and a modular platform, very compact form factor, 4-rack unit, and you can individually choose different types of line cards. Again, we offer 4 ports of 400 gig or 16 ports of 100 gig or 16 ports of 25 gig. So if you don't want to deal with the kind of the breakout, options, then, choosing this sort of modular platform is the way to go, where, again, it's going to give you that flexibility where you can go from 25 gig to 100 gig to 400 gig in a single box over several generations. And also when you're doing migrations from 100 gig to 400 gig, this turns out to be a very, very interesting option for those scenarios. And anything that I've discussed from 1 gig all the way to 400 gig, common feature set, we support, EVPN, VXLAN on all of these particular platforms to help you build your data centers, and a ton of flexibility. So now we're going to switch gears and talk a little bit about sort of, the transceiver form factors, as well as to kind of what you will need to build these networks. This slide just sort of shows you that, again, of course, today we build 25 gig in the top of rack with 100 gig in the spine. But as you think next generation, 100 gig in the top of rack and 400 gig in the spine, these are some of the building blocks to consider. And I also kind of show, what do we consider as more of a general purpose compute? That would be the SDX4 platform, the DSFP form factor. And if you're looking for a storage in HPC and AI/ML, that could be the CX4 platform with 100 gig and 200 gig connectivity to the server. Gary, I know you're going to take us through the transceivers now.
Great. Excellent, Salman. So yeah, we're going to switch gears a little bit and dive a little bit more into the transceiver options that Arista offers today. So I'm going to go ahead and with that, I'm going to start and just kind of go through and for maybe a little bit of background for folks and go through the evolution of the form factors itself, because there's been a lot of change over the years and different terminologies that not everybody might be familiar with. So if you look at the SFP family, really started with the SFP Plus, and then the associated speeds that really we see with each form factor. So the Plus, the 28, the 56, and as Siemon mentioned, the new form factor in this family is the SFP DD. So as with the X4 platform that Arista has, as he mentioned, currently that is available just with DAC cables today. So this is for, again, 100 gig. But likely down the road there will be optical options as part of the specified in the SFP DD MSA. Then the next family is the QSFP family. So started with the Plus for 40 gig, moved to the 28, and the 56 for 200 gig. And then as Sam mentioned, really it's been now about 2.5 years roughly that the new 400 gig form factors came out, the DD and the OSFP. And as we've talked about, Arista does offer both of those options. I will highlight that not everybody does offer both options, and some manufacturers only offer the DD. So as folks are looking to go into those, especially the higher speeds, even up to the 800 gig and beyond, where OSFP definitely has an advantage. It was really purpose designed for those higher speeds with lower power usage utilization. So with that, then I'm going to kind of dig into a little bit the different options from a transceiver standpoint. And I'm not going to go through every specific detail on the slides here, but I really wanted to highlight Siemon works pretty closely with Arista as well as the standards bodies. I personally represent the company at IEEE, so pretty tied into current and future developments. And really the purpose is to, again, present and educate people. A lot of my job is helping educate customers and understand the technologies and the options that are out there. If you look at the 100 gig, space, there's at least 9 different options. Actually, there's more than that because we've doubled up some of these. So, Arista has, it's probably a dozen or more 100 gig different options. And if you look, these are, because some of them have different fiber types, they have different connector types and different interfaces. So the bottom half in the kind of greenish color are all single mode options, and the top couple 3 options are in the multi-mode. And if I just to kind of highlight the top runners and the ones we see most often. So number 1, the SR4 is one of the most common that we see in the marketplace, very common. I'm going to skip down to number 3, the BiDi. That was became popular with the 40 gig front, and now we've got the 100 gig option. So BiDi stands for bidirectional, and that still does utilize a duplex footprint in the LC. And then there's a lot of single mode options, as you can see here. And some of the options there. The early days, I think, with 100 gig, and there's still a good amount of volume on number 4, the PSM4, that does require an MPO connector. And then, really I'm zeroing in on number 7, 100 gig DR, the duplex single mode. That one, really, we've started to see that in the last 1.5 or 2 years. The volumes really picked up on that, and we're seeing quite a bit of options there and usage. So I'll go and I'll give you some comparison of those coming up. So moving on to, if we start looking at the higher beyond 100 gig, I just kind of want to highlight some of this is really just terminology, and for reference, there's a lot of new terms and technologies that are out there. So the first is SR8, and that really refers to it's a multi-mode solution. It does require an MPO 16 connector, which is really kind of non-standard, not very common in the industry, but that is what's required for this particular application. The BiDi, which I mentioned also, the 100 gig option for that, that does still utilize the same MPO 12, still 8 fibers from that, like we've seen with 40 gig SR4 and 100 gig SR4. And then the other one, common one that we're seeing is the DR4 on the single mode side. So that also single mode requires an MPO connector. And then the last one is the FR4 and LR4, duplex, single mode, 2K or 10K reach. So those are just from a terminology standpoint. Now, if we take a look at what's available, what Arista offers on the 200 gig front, there's really only a couple options that are out there. There's not too many folks that have utilized 200 gig. Most have kind of skipped over to 400 gig, but there's the FR4, which is a duplex single mode, and the SR4 is a multi-mode, does require parallel optics. So really two options, and these have been pretty specific with different customers using for their particular applications. And if we look at the 400 gig front, there's really 5 basic options. Kind of highlight again at the top there in the greenish color, the single mode, and down at the bottom are the multi-mode options. If we just kind of highlighting a few things here, the top runners really in terms of volume and usage are number 1 and number 2. So the 2 single mode, the FR4 duplex single mode, and the DR4 is the single mode parallel. On the multi-mode front, I'm going to talk a little bit about that. Currently available today is the SR8 from Arista. That one is the one that utilizes that MPO16 connector that I mentioned. There hasn't been a whole lot of adoption, market adoption on that. It's just because of the non-standard interface. The next one down is the 400 gig BiDi, which technically by the IEEE standard is called SR4.2. That one will be available fairly soon from Arista, estimated in Q2 of this year. So that will also utilize the MPO and MPO12 connector. And then a little bit beyond that is another new option that I think could be a good one is the SR4. So this is from an IEEE standard, the IEEE DB, I believe, that just was published in December. So relatively new, but that could be a good option as well as we look for folks, especially in the enterprise market where a lot of individuals have a existing multi-mode installed base. So to be able to migrate that multi-mode cabling to these higher speeds. So the 100 gig, there's a pretty seamless path, and 400 gig, there's some good options, whether it's multi-mode or single mode. Okay, next.
I got a question for you on the previous slide. The 400 gig BiDi that Arista is introducing, that's also going to be compatible with the existing 100 gig BiDi install base as well. So ultimately, I think what it helps customers to do is to reuse a lot of the existing install base of 100 gig BiDi.
Correct. Thank you. Because yeah, exactly. That one's because that'll have the breakout capability to go back to the 100 gig BiDi as well. Yeah. Exactly. Thank you. Next thing it did was put together a channel pricing comparison, just looking at the common ones, and this is looking at 100 gig right now. So I picked 5 of the common transceiver types that are used, and just looking at the relative price difference between them. So this is so again, this is the optics. So it's 2 transceivers, 1 on either end, and then the associated fiber cabling. And this is looking at kind of based on average sell prices in the market for all the transceivers and the cabling. The fiber cabling would be either the 2 or the 8 fibers for the associated multi-mode or single mode. So if I kind of go left to right, we've got the SR4, the multi-mode parallel, the BiDi multi-mode duplex, PSM4 single mode, the DR single mode duplex, and then the CWDM4 single mode. And just a couple takeaways, I guess, if you look at it, if you haven't looked at this in a while. The first is that you could see between multi-mode and single mode, they're pretty much on par with each other now. Single mode optics costs has come down pretty significantly over the last several years, where there used to be maybe a 5 to 7x delta between multi-mode, but now they're pretty much on par with each other, as you can see here. The other thing I wanted to highlight, the CWDM4, that one versus the DR. So that one, the CWDM, has been around for several years, and it's pretty common. It does have a 2K reach, but the cost of that is pretty significant. Almost 5x of the DR. So for, especially in the enterprise segment, most of those customers don't really need the 2K reach. So it's a good option, and I've recommended this to many folks, if they haven't looked at it, to evaluate moving to a DR if they don't need the CWDM. Next one, I just did a quick comparison on the 400 gig front. Not a lot of options here, and again, this is the relative price difference from each other of the channel, and really just have three options that I show here. The BiDi that's coming soon, as I mentioned, and then the two single mode options, the DR4 and the FR4. And really the key takeaway here, as you can see in this case, the BiDi is going to be expected to be more expensive than the two single mode options. So those continue to, really the majority of the, as you can see, a lot of the options moving to the higher speeds are really around single mode. There are some multi-mode options, but current multi-mode options are not great. That's why I think the SR4 likely will be a little bit less expensive than this one. So there are options, but just for a comparison's sake. So next, to what I want to do is just take a look at what does that mean then from a migration standpoint, going from maybe these the 1 gig or 10 gig to the higher speeds. From a cabling standpoint, what does that look like? So I pulled a few examples, typical examples, to share with everybody. So the first is looking at the application of switch to switch, right? So, and this could be either 100 gig DR or the 400 gig FR4. So kind of looking at either from a cabling standpoint, it looks the same. This is a 2-fiber single mode channel. And what I'm highlighting here is just, again, a typical channel that we see. So in the middle, I've got MTP to MTP cabling using a base 8 MTPs. That goes into cassettes on either end, where I'm converting those right into LCs. I'm plugging those LCs into my transceivers, into the switches right from either end, whether it be a DD or a 28 port on either end. Pretty straightforward, pretty common from this standpoint. And this same channel obviously can be used, 10 all the way up to 400 gig. Another example that's pretty common, still looking switch to switch uplinks, the 100 gig PSM4 or the 400 gig DR4 single mode. So this does require the 8 fibers that's utilized for those options. And you can see pretty much the same in the middle, the same thing as the base 8 trunk. But instead of converting these to duplex LCs, I'm just using adapter plates on either end. And then from that, I'm going to just use a standard 8 fiber jumper. So again, this is why we're really recommending, it makes sense to use the base 8, because each of these the transceivers only utilize 8 of the 12 fibers in there. So you've got 8 fiber jumpers on either end connecting into both ends. Taking a look at one of the things that's very, very common that Siemon mentioned as well is breakouts. There's a lot of different breakout scenarios, a lot of different use cases. I've got a couple that I showed here just to give you examples. So this one's still looking, let's say, a switch to switch, and this could be 100 gig on one end and breaking it out to 425s on the other, or 400 to 400s on the other end. And what that looks like, you still have the same backbone cabling in here. On the DD port side, I'll say 400 gig, I've got my same 8 fiber jumper here connecting into my backbone cabling. And then on the other end, I've got there's a lot of different names for this, conversion cassette, breakout cassette, but it really basically goes from an MTP to an LC and still makes duplex channels out of that. So you got an LC cord, and then I'm going to plug that into, let's say, four different QSFP 28s on the other end. Again, very common. You could also do this with a cable assembly. As an example, you've got there's another, an MTP to LC kind of equipment cord that you could also do on this end instead of a cassette. So again, a variety of different ways to skin this. This is a pretty common one that we see out in the market. So I'll take a look now on the multi-mode side. So this is still switch to switch. And this is looking at 100 gig SR4, as I mentioned, or the 400 gig BiDi, the SR4.2. So those applications require an 8-fiber multi-mode MPO connection. And same idea as the single mode, as I mentioned there, you've got in the middle of the backbone, it's base 8 OM4 cabling on there, going into adapters and then plugging in with the standard 8-fiber jumper on either end. And this, as I mentioned before, this channel, this looks the same, whether it's 40 gig SR4 or 100 gig SR4. So either one works for this, and they look the same. The breakout that I mentioned, the single mode, looks the same for this one as well. One other example that's a new option that Arista offers I wanted to highlight as well is another breakout scenario. So it's a switch to switch, but with a 400 gig option, they've got the DR4-S, breaking that out to 400 gig ports on the other end. And that DD transceiver utilizes a new fiber connector called an SN. So it is a connector interface that there's, you can see here, basically it accepts 4 of those duplex connectors. So 8 fibers, 4 connectors that plug into that transceiver. And this is really showing leveraging that that capability in the breakout, but still connecting it through the common LC infrastructure. So in this case, I've got a hybrid, what I'd call patch cord, SN to LC cord, plugging into my LC cassette, and then the same channel that I showed you before. You got the cassette on the other end, and then I still got my standard LC cords plugging into my 4 QSFP28 ports. So it does maintain that flexibility of having a structured cabling system and patching on both ends, and still leverages the capability of the breakouts with the DD module. So the other thing I wanted to show just some examples as Siemon was talking about, at the top rack switch and down to the servers. That's kind of the last piece of the equation is that switch to server downlink. So I want to just kind of show there's really a few different ways of few options really, and I want to kind of go through and there's really pros and cons to each one a little bit. So what I'm showing here is a 25 gig switch to server. So you've got one of the Arista switches that Siemon showed at 100 gig up, 25 gig down, and standard SFP28 transceivers, going into my server side as well. And, I could be using a standard cord in if it's in a top of rack, or if it's an end of row, you might have patching as well. But, one of the benefits obviously with a transceiver is there is flexibility. So you can go from a 10 gig or 20 to a 25 gig, right? And service each port. You also have the benefit of, if there is an issue, you can service individual ports on that switch. So again, pros and cons a little bit with those. Another very common option are DACs, direct attached cables. This is showing that same switch and the same server. And in this case, there's a single DAC assembly, SFP28 to SFP28. And the key benefits of the DAC is really lower latency and lower power than the transceivers. That's a key reason why we see this very commonly, especially in the financial sector. Those customers where latency is very, very sensitive. The other thing that, from a benefit standpoint, DACs are very cost effective. It says 25 gig, but it's 10 gig as well. So just as a reference, if you were to compare just the last option with 2 transceivers and just a standard LC cord versus this option with the DAC, the transceivers and cords, they're probably 6 to 7 times the cost of a DAC equivalent. So pretty significant. The downside, one of the disadvantages here is the reach, right? You've got, depending on the speeds, call it 3 to 5 meters max reach. But very common option. And then the last one that we see is AOCs, active optical cables. And this is as we start to see more 100 gig at the server, as Siemon was talking about. It's a real good option for that, especially fiber. This is obviously fiber, so the cable is small, better for airflow and cable management. Does have the lower power, as I mentioned, versus transceivers. So, and it is a fairly cost-effective solution. This can go a little bit farther. We typically, recommend up to maybe 30 meters. So it's kind of in that window of, 5 meters, above 5 meters up to 30. Because then typically you're, once you get too far, even at the 30 meters, you're probably doing structured cabling. But it is a good option that we see out there as well. Now moving on to campus networks. Siemon, I'll back to you.
Thank you, Gary. First of all, thanks to you. I mean, like I said, when you're thinking about building sort of these next gen networks, particularly when you start reaching into this 400 gig area, it's really important to consider all these new optical options, as well as, kind of carefully considering cabling, keeping in mind backward compatibility and connectivity to different kinds of speeds and breakout options and so on and so forth. So thank you for enlightening us with that discussion. So next slide, please. We talked a bit about sort of, what's happening in the data center, particularly in the server evolution from, 10 gig to beyond. And of course, kind of how the uplinks are changing and so on and so forth. But also, I mean, the data center is really not the only place where the change is happening. We are obviously coming back from COVID after 2 to 3 years. People are sort of rethinking how they're going to build their campus networks or buildings where they house employees. So there's a lot happening there in that area as well. So and so we have to kind of think about that. So one is obviously, if you kind of look from down to up, is the use of the pervasive video, right? Not only what I really mean by that is basically just, there's going to be more pressure on the bandwidth, particularly with the introduction of Wi-Fi 6 and 6E. Every endpoint is generating a lot more content. A lot of the content when you are on campus, maybe video, being on Zoom calls. I know lots of us take Zoom calls from home, but let's say people who are in the office may also be on Zoom calls to connect with other employees or colleagues or whatever have you. And then just do keep in mind that the endpoint capabilities are improving itself with Wi-Fi 5 and 6 and 6E now, and 7E coming soon. So just sort of, that's one big change that's happening. Second thing is, keep in mind that, there's limited on-site IT. So there's a lot of emphasis and focus when we talk to our customers on automation, just really simplifying things. And, whether it's through novel architecture, whether it's through the management platforms, particularly in the case of Arista with Cloud Vision, with our what we call as a sort of a converged unified edge, or Q, by making sure that we can manage our wired and wireless infrastructure from a single pane of glass. So that's sort of very important. With working anywhere, obviously, your security becomes very, very important. And when I talk about security, I also want to make sure that there's a sort of explosion of IoT devices, whether these are sensors of various kinds and whatnot, which, there's not a typical sort of standard way of, providing security for these IoT devices. So we really have to kind of rethink the security architecture. The kind of the common term that's often used today to describe some of the security challenges or the evolution of the security architecture is called zero trust security. So Gary, if you can kind of move to the next slide, I want to kind of talk about a few things. Just build out the full slide. So again, so let's stay here on this particular slide 33. So let's talk about sort of the big changes. Some of these campus networks have been around for well over 10 years. we have been at the 100 meg or 1 gig speed. Really, only now within the past couple of years, the big transition to what we call as a multi-gig speed is starting to occur. And much of that is being driven by two factors. Like I said, one is kind of the emergence of these new Wi-Fi standards that requires higher bandwidth to connect, 2.5 gig or 5 gig, and very soon 10 gig copper over power over Ethernet. And then the second thing is just kind of, the emergence of high bandwidth applications such as video in the network is also, kind of pushing customers towards doing these sort of, generational change to this next gen multi-gig networks. The impact on what's going to be the impact on the infrastructure and cabling, I'll leave it to Gary to discuss that. Second piece is zero trust security. Particularly from the Arista's point of view, we think that the security really has to be part of the network instead of it being a kind of a bolt-on capability. So what we have done more recently is we have built in these network detection and network threat sensors within our own power over Ethernet switches. So not only the power over Ethernet switches are providing you the Wi-Fi connectivity, the user connectivity, but ultimately they're also working as security devices that are providing security to not only physically connected devices, but also IoT devices. And that's a huge transformation that's going to happen over the next few years. Like I said, we are really kind of moving from kind of, the manual operations, particularly with the current environment where half of the people are working from home, the IT teams are not situated on site. The network automation is really the key to supporting the next gen campus or buildings network. So we are focused quite a bit on making sure that we provide convergence of course wired and wireless management, but also providing you rich telemetry to really effectively manage these networks. And last but not the least, being able to do so with the really quality of experience. And one of the things, of course, we won't have time to kind of get into the details of our solutions, but we do provide a lot of rich telemetry to provide quality of experience for variety of applications, whether it's Zoom, Teams, or other emerging video applications. Next slide, please. So in terms of the data centers, we talk quite a bit about going from 10 gig to 25 gig, potentially 1500 gig and 400 gig to the spines. I would say campus obviously does not have that kind of similar stress in terms of the bandwidth. So really the two big things that you ought to remember is that on the PoE side of things, we are finally transitioning from 1 gig to 2.5 gig, 5 gig, and potentially 10 gig soon. But the uplinks, if you look at my top part of my slide, really going to be potentially 10 gig, 25 gig, and 100 gig. We're not really seeing kind of the emergence of 400 gig in the campus just yet. Maybe to connect different buildings, maybe to connect DCI, certainly in the data center, but not so much in the campus today. The campus connectivity mostly is going to be focused around when it comes to kind of the aggregation switches, 10 gig, 25 gig, and potentially 100 gig. And downstream on the user side, really focusing on 1 gig to 5 gig today and potentially transitioning to 10 gig copper over PoE soon. So with that, Gary, let me give it back to you and you'll wrap it up for us.
Great. Yeah. Thank you, Siemon. So just kind of continuing on the campus side. So really looking at the applications from a cabling infrastructure standpoint. So the same applications that Siemon was talking about. Here's just an image to kind of highlight really what we see from a commercial building. So on the side here, just representing a typical multi-story building, several floors within there. Within that typical building, you've got an entrance facility where the incoming cables are in, and then you've got several floors typically within there. So this is really your just kind of typical architecture that we see within there. And then in each of those, there's a telecom room within there on each floor. And this is where you've got the switch that Siemon was just highlighting, one of those switches. And then out from there, you're going out to your devices. So whether it's the WAPs, whether it's the video, and we're starting to see more and more intelligent buildings, obviously, and there's a lot more end devices that need to be managed. So typically from a cabling standpoint, you could see here highlighted, you're running fiber cabling as the backbone between floors typically. And then the horizontal cabling is typically copper. For most of these applications now, we're seeing category 6A as pretty much the standard go-to for WAPs, as well as all the other applications to handle the bandwidth that's out there. So pretty common that we're seeing today. So from a let's see just a summary solution side, for those of you not too familiar with Siemon, again, we are a 120-year-old manufacturer of copper and fiber infrastructure. That's what we do. And here's just a sampling of our best-in-class copper. So whether it's the jacks, patch panels, patch cords, all the cabling to go along with that, to install in all the campus networks. And then on the fiber side, again, typically in an enterprise space, you've got, you've got bulk fiber, you've got the enclosures and the patching and the cords that go all along with it. So just kind of a high level summary, but all that information is on Siemon.com. So just wrapping it up here, I think we're right on the hour. I think we're doing good timing. To summarize, covered a lot of information here in an hour, but there's a lot of trends and applications that are driving need for these higher speeds at 100 and 400 gig. Several different use cases that Siemon highlighted, and as you can see, there's a lot of equipment available. On the 400 gig front, the platform that Arista just introduced last month, I think they're on the 3rd gen of the 400 gig equipment now. So we're seeing a lot more market adoption and volume there. I listed a lot. There's a lot of options from a transceiver side, and the breakout use case, I went through a couple, but there's many more, and really kind of look at individual applications. And Siemon highlighted really that the cost per port continues to go down with those higher speeds. So as you go on 100 gig and 400 gig, you're able to break those out. Thus, the result is lowering that cost per port. And really, we're, Siemon and Arista are here really to act as trusted advisors and help, end users, data center operators understand these technologies and the potential solutions to help with those. So with that, I will, I thank you for your time. We'll open it up if there's any more questions. I know there were some that came into the queue, but